Hello, I'm Peter Lawrence from the National Centre for Atmospheric Research, and today I'll be presenting on understanding carbon dioxide removal and management within the Community Climate Intervention Strategies program at NCAR. I'm presenting on behalf of the steering committee, so this is a large group of people. This is also a project that's been funded by the UCAR President's Strategic Initiative Fund and NCAR Lab Directors and the National Science Foundation. Before I get going on terms of the Climate Interventions Program, I just wanted to sort of put it in the case of the growing urgency and the climate disasters that we're experiencing and the cost of those disasters. As we can see that there have been like wildfire disasters in California and Colorado this year, but also increasing numbers of hurricanes, number of named storms. And as we see the cost of these is piling up, we're starting to think of perhaps there must be some way of addressing some of these problems through some climate intervention type strategies. These problems aren't just related to North America. We're seeing these globally. So we're seeing unprecedented fires across the world through the Amazon, Borneo, Australia, Siberia, but we're also seeing record droughts. We're seeing record flooding, heat waves, coral bleaching events through the Great Barrier Reef, other areas throughout the world. We're also seeing large losses of the Greenland ice sheet and repeated cyclones hitting the Philippines and Nicaragua. So the Community Climate Intervention Strategies program, which was being supported by UCAR and NCAR, has been set up over the last year following a series of workshops. And from this, we've developed a mission where we're going to develop actionable research to understand the effectiveness and impacts of a portfolio of climate intervention strategies that, when combined with mitigation and adaptation, can achieve a climate-safe future for human and natural systems. We have some main goals associated with this program. We look to establish communication between currently disparate research communities and to develop a unifying interdisciplinary and international research program. We wish to establish and support integrated working groups, support interdisciplinary projects working towards scientific assessments. We want to enhance communication, synergize existing efforts, and cultivate new research. This is a little bit of the history of the program so far. We've got backing by a number of international coordinating groups. We have had a NCAR Climate Intervention Strategies workshop last year. This year we've run a webinar series. We've developed a research framework and developed a website. We have just recently finished the Community Climate Intervention Strategies workshop, which was held in October 28 to 30. So this is a look at our steering committee. We have a diverse steering committee coming from across NCAR and UCAR, but also with external members. People have come from all different types of backgrounds to be part of this program. Okay, so I'll just give you a bit of a background in terms of the last year. Last year, we sort of categorized it with webinars, website development, and our workshop. The first element was to develop a conceptual framework for what it is. And so getting an understanding of the research community, identifying existing efforts in this sort of role, and trying to understand what are all the challenges that we face to develop a community like this. From that point of view, we had a webinar series where we had 8 different topics. This was very diverse. We had expertise of 27 speakers within this webinar series. And we've got 16 hours worth of presentations and communication. It's well attended. We have 75 to 160 people online for all the webinars. And all of those discussions and summaries are available on our CCIS website. And this creates a research framework and allowed us to set up the October workshop. The October workshop was held, as I said, October 28 to 30. We had 250 international attendees with 120 people working within the breakout sessions. All sessions of that were recorded and available on the CCIS website as well. Down here we see the CCIS website, www.ccis.ucar.edu. So to give you a feel for what the webinar series was all about, we had a very good introduction from Will Stefan, who talked about Earth system trajectories. And what he was really getting here was the concept that the Earth system, as it changes, has stable climate states that it can exist in. And there are certain transitions between different climate states that are easier and harder than others. So if we look back at the Pleistocene, we look about 1.8 million years of glacial, interglacial cycling. And you can see that from the stability diagram here, you can see that like a glacial period is a fairly stable period. and then can move into this interglacial, and then it moves back into the glacial period along orbital forcing, and you can see that through the time series down here. Prior to that, we look at the Pliocene, where we had 3 million years of stable, warm climate. So Will's concern, and ours shared with us as well, is that right now where humanity and the Earth system is right now, we have a choice between Earth system stewardship, where we take Earth into a stabilized, less dangerous area, or we start looking at business as usual and hitting serious planetary thresholds, where we take Earth into this stable hothouse Earth that's very hard to get back out of. One of the things that was very of concern to us is the UNFCCC was first set up in 1992, so almost 30 years ago. And during that period of time, we have a series of aspirational goals and aspirational sort of agreements. However, very few of these are enforceable. And during that same time period, we see that CO2 in the atmosphere has continued going up along the business as usual case. And we see the associated warming through the climate system. So what the Community Climate Intervention Strategies program is about is looking at, are there potential climate solutions that humans can deliberately take or intervene in, that such that they would take us onto a climate that is off the business as usual case. Here we see the first step is always to cut emissions aggressively. The second part is looking at carbon dioxide removal. The third part is looking at other forms of climate, such as stratospheric aerosol injections, marine cloud brightening. So this is how we basically premise a pathway to a climate safe future. Mitigation is necessary to reduce emissions to net zero. This is a long-term process. It's requiring strong political will and societal and economic transformation. Beyond that, we need to look at carbon dioxide removal, because past and current emissions have already given us climate impacts that are committed into the system. As we continue with ongoing emissions, we commit even further. So there's a need for negative emissions. So this program, we're looking at land management through reforestation, afforestation, agricultural practices, restoration, bioenergy and carbon capture and storage, industrial processes such as carbon dioxide removal from the air, also transforming like carbon intensive industries. We look at ocean-based carbon dioxide removal. Beyond that, we're looking at adaptations. How do we minimize the climate impacts by protecting vulnerable systems? So we're looking at the impacts of climate change on biological processes and ecosystems in terms of how sustainable they are, but also looking at human systems such as water, food, energy, infrastructure, industry, and health. Beyond that, we're starting to look at targeted regional climate modification to prevent some of the local climate impacts. Here we're looking at albedo modification through land practices and snow and ice management, but also localized marine cloud modification, such as projects that have started on the Great Barrier Reef. Finally, we're looking at global solar radiation management, where we're looking at minimizing climate change by immediate changes in the planetary energy balance. So this is looking at things such as marine stratocumulus cloud modification, cirrus thinning, and stratospheric aerosol injections. Because this talk is focused on carbon cycle, I will not be looking at the other components of this, but just looking at the carbon dioxide removal and the carbon storage. So one of the things to look at is that the IPCC special report on 1.5 degrees of climate warming focused on 4 different trajectories, all of them to try and achieve this 1.5 degrees of warming. As we can see from here, all of them revolve different amounts of reductions in emissions over the 21st century. But what we can see is that offsetting those, we have a large amount of agriculture, forestry, and land use, such as reforestation and afforestation in each of these scenarios, as well as looking at bioenergy and carbon capture and storage. It's the combination of these together, so they can offset each other. But it's always a combination of different activities to try and get a net rate of warming to 1.5 degrees. From our work, we've also seen that beyond land use and land cover change and BECCS, we also see that agricultural nitrous oxides and agricultural methane are very big and important components to understanding the net climate impacts. Beyond that, we're looking at diet as well. So how does both the calorific or kilojoule that are consumed by the global population, and also the composition of like meats and vegetables and cereals and grains, how do they impact the total amount of area needed for growing food, and also what that means in terms of the carbon cycle. Here we can see that an Indian diet If everyone had an Indian diet in terms of calories and also profile, we have a very small footprint. Whereas if everyone in the world had a US diet in terms of profile and content, then we have a much, much larger, in fact, 5 times larger area of land. We looked at direct air capture. So we're looking at what the industrial process to suck CO2 back out of the atmosphere and capture it and store it in geological reservoirs. Finally, we're looking at how do you transform industry and use the carbon that you capture to store it in materials and processes and offset carbon intensive processes as well. We looked at how do we compare different ways of doing carbon capture and storage between natural working lands, which can be cheap but have smaller carbon abilities, up to through the biofuels and then into the direct air capture, and seeing that there are different costs, but also different potentials for each of these different mechanisms. So finally, what we can say is that out of our workshop, we've come up with these 7 different working groups that now form the basis for the climate intervention, the community climate intervention strategies program. So we start off with societal decision making. We have physical processes, so we're trying to understand how all these different components of climate intervention interact with each other, whether they're land management and industry, ocean-based, understanding how the Earth system feedbacks and tipping points work within the system, cloud modifications such as the marine stratocumulus, cirrus thinning, stratospheric aerosol interventions. And part of this is trying to understand the impacts of the different strategies, but also how the systems respond. So we have a working group looking at societal and ecological impacts. We want to understand both biological processes and impacts, but also understanding all the human components to that as well: water, food, energy, industry, and health. We're looking at targeted regional impacts. So whereabouts do climate interventions impact, such as polar regions, forests, Great Barrier Reef? And also, how does socially do this affect? How do developing countries get impacted versus the developed countries? One of the working groups we're looking at is scenario development. How do we have a series of scenarios that can be used by the community for both doing research level process forcing or activity versus policy relevant scenarios where we can have a portfolio of plausible actions that can be given across to a policymaker. Finally, we're looking at a knowledge exchange outside of the sciences. So how do we bring in our education and outreach facilities? And finally, we're looking at co-production of knowledge and interdisciplinary research. How do we actually build a community like this? How do we ensure that the values and the priorities of stakeholders are included in our research program? So that brings us to the final slide, which is looking at the unified research framework we've developed. Here we can see all of the components of our community as we want to bring them together. And these disparate research groups need to be able to facilitate and exchange information between them. But we also need to be able to get this information out to stakeholders. So with that, I will bring an end to the talk, but I'll be very happy to answer more questions when I'm at the live session. Thank you very much.